So you should come tomorrow also. The organizers must not say that, in the first day itself the whole thing.
We have preserved the energy till last day.
If there are any questions that I can possibly take, you have not understood something or you have a point of view, it is the best time to shoot. What is? It is high level synthesis for machine learning. H for high, L for level, S for synthesis. Instead of FOR, they have put that
FOR.
And
She's talking about the tool, huh?
Yeah. It's a good tool. You try it.
Can we carry out some projects at the undergraduate level with the help of that?
Oh, certainly.
It's open source.
It's open.
Wonderful.
Actually, I think up to recently, the use of TPU itself was open source, but I think about 6 months or so before they have stopped. Otherwise, they were allowing virtual porting of design running it in the TPU. Because even they need that training data set. Now they have stopped it, unfortunately. But still, if you have a decent FPGA in your lab project, you can build hardware accelerators, publish papers.
Any simple FPGA is sufficient?
Simple, I will not use the word simple, I will use the word not costly.
Not costly.
It should certainly have an ARM cortex. You will need it for scheduling. Otherwise, to sit in a lab and have an external scheduler and have connection between two boards and establish communication, that you will give up in 3 to 4 months. In industry, they can persist. So if you have a ARM cortex in the FPGA and you have onboard memory, through DMA controller, it is easier to establish the data flow. Then you can do a lot of experiments. You can push your ideas, develop IPs, patent them if your college can give you the fund. A lot of things you can do. So I am not saying simple, but I am saying not costly. Something that comes for 25 to 30,000 in the open market. But because of the policy, there is a, if you understand the market dynamics correctly, Altera has been acquired by Intel, isn't it? And Xilinx is the major FPGA provider. So if you try to buy Xilinx board, the good part is their tool suite is very good. Vivado design flow is very, very good. But the board is costly. If you want a decent board, it will cost you 3 lakhs, 4 lakhs, 4 lakhs like that. And if you really want an SoC board on which you do some real research, it goes up to 14, 15 lakhs. But that is high-end research, not with students and things like that. But with Altera, because they could not establish themselves so well in the market, so I don't even know if you have heard of their Vivado. You have heard. What is the equivalent Altera to? I think you have heard of it. It's Quartus. So they give their boards cheap. And if you catch hold of the academic coordinator of Intel, his name is Professor or his name is Kalyan Raman. Padmanabhan. He will be coming, right?
He will be coming day after tomorrow.
You can take. He is coming for 2 sessions, I think.
4th day he is.
2 sessions, correct? No?
2 sessions.
If you coordinate with him, they have a university academic program. So you can get a few FPGA boards from them. That should be more than enough to carry out decent research. I will not say top end cutting research. Decent. And developing a hardware accelerator does not require too much of logic on an FPGA. If you are hell-bent on saying, illa nanu Google tara 64,000 processing elements haki, one network on chip ಮಾಡಿ ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಅಂದರೆ ನನ್ನ ಲೆವೆಲ್ಗಿಲ್ಲ ಆ ಥರ ಹೇಳಿದ್ರೆ ಬಟ್ ಇಫ್ ಯು ಆರ್ ಸೇಯಿಂಗ್ ದಟ್ ಪೀಪಲ್ ವಾಂಟ್ ಟು ಡೆವಲಪ್ ಅ ಪ್ರಾಪರ್ ಹಾರ್ಡ್ವೇರ್ ಆಕ್ಸಲರೇಟರ್, ಟೆಸ್ಟ್ ಇಟ್ ಔಟ್, patent it, put it in the standard cell library or the IP library in a standard cell library in ASIC or the IP library of FPGA flow. I think that's a wonderful achievement. If I can open Vivado and instantiate your IP into it, what more do you want actually? So that much is enough. It is our overthinking and comparison that is the source of our misery. And we lose the reference of the context also. See, you are a single person, right? With 2 subjects and 4 labs, plus NAC, plus NBA. And I should look this side and say I am on HOD on top of your head. If you map your working style to a corporation which is employing thousands of people, that is not fair, no? But yet you can come up with IP cores that is better than what they develop. This has been my experience. If you concentrate on one, again if I say one Hindi poem, then you will again say this fellow is deviating into poetry instead of being in FPGA. But there is a very good poem written by Harivansh Rai Bachchan, Amitabh Bachchan's father. It goes with the title Madhushala. So he is explaining life with respect to the place where liquor is given, Madhushala. But it has got nothing to do with liquor. So he says, पीने के लिए रोज निकलता है हल्का प्यासा. The fellow who needs, so you substitute that for knowledge. A fellow who needs that, every day he comes. किस पथ जाऊं? Anyone who understands Hindi? So you must be knowing this. किस पथ जाऊं? असमंजस में है वो भोला भाला. Which path I should take? That humble fellow is in confusion. अलग अलग पथ बतलाते सब, लेकिन मैं ये बतलाता हूँ, राह पकड़ तू एक चला चल, पा जाएगा मधुशाला. One IP, pursue it. But our problem is when we are doing one IP, that fellow is doing 5G, this fellow is doing 6G, that fellow is already seeing 7G. So finally we are left with no G. So that is the basic thing. But one simple FPGA which has an ARM Cortex, and that ARM Cortex only for scheduling the DMA data flow. Otherwise it becomes really difficult. Having an external microprocessor and setting up a data path, then buffering inside, not needed. So we should not simply do research for the sake of doing, right? Illa nane kashta patto. Adu heltaralla, kashta pattu maadabardu, ishta pattu maadabeku. So let's eliminate the we will stick to our IP development. Why I should go into scheduler design? Correct, no, get into OS, put one Linux on that, and again learn how to instantiate Linux, how to take the image of the Linux kernel that I want, because you can't dump the entire Linux on chip. Why get into that is my question. You use what is available, let's not reinvent. Take a SoC FPGA, limited resources, just ensure that it has an ARM Cortex with DMA and concentrate on your IP design. This is for people who are looking to work on digital side. Analog side, there are so many open source, free software for analog design, for the entire design flow. There again we should be a little careful, as in, why should I bother about what the technology node on which I am validating my IP? So Aditya, we should get rid of our insistence on things that are perceptible. See, if I design a neuron, analog mixed signal neuron on design model, if I design, why should I validate it on 3 nanometer only? Because the 3 nanometer validation will be extremely costly. 180 nanometer validation will be extremely cheap. But an IP doesn't require you to validate it on 3, because the IP or the patent is for your idea, not for the product. Because if you have to patent that, then you have to make an ASIC test and then say my idea is working. Correct. So for 180 nanometer, you have wonderful free tools. You need not even look to Synopsys, need not even look to Cadence. If you have, very good. If your college has it, very good, use it. But all I am saying is it's not a bottleneck. Open source, tumba tools. So many tools. Concentrate on that. So nothing, no questions to be asked. I'll put up a small problem statement. I don't know whether I have brought in paper and I had asked them to share it with you. So I'll take an essence of that and continue with that in my last lecture, so that you will be sort of little prepared for it. So let's take the example of multiplying 2 3 cross 3 numbers. Start from a very simple example. Right? Now I'll give you one multiplier and one adder. Right? You think about what is the sequencing of data on this data path that will do the job for us. Think about it. I have one 3 cross 3 matrix A. I have another 3 cross 3 matrix B. I want to design a data path. So the data path that I am giving you is a multiplier and a adder. Alright? How do I now, the question is, how do we sequence data on this data path to multiply 2 3 cross 3 matrices? Can you imagine? One multiplier, one adder. How do we go about it? What are the, how do you send data? Which is the first data you will send?
First element of first
A11, A11, then B11 to the multiplier. Till then the adder is not doing anything. Yeah. Alright. Now you get A11 into B11. You temporarily store it. So there is another temporary storage which is feeding the adder. Correct. Then you are sending what data to the multiplier next, and then B21. Taking row here and column there. Correct. After those two multiplications have been done, now the result of those two are being added. Now, while they are being added, the multiplier is free, so you can schedule the next two coefficients. Correct. Obviously, correct. So you can at least do some pipeline. Correct. So you do this row, this column, this row, this column, this row, this column. Alright. You generate all the 9 elements. Correct. So evaluating the computational complexity of this is really easy. Nothing great with this. Now, let us say I give you a 3 cross 3 matrix of multipliers and adders. 9 multipliers and 9 adders. Now, I have increased the number of data elements because I have enough space. Right? Now, how?
Actually, we can do the first 3 multiplications. So in one stroke, then 2 additions in second stroke, and so on. Can we do that way?
We can do that way. But what is of more importance in designing a hardware is, look, you have 9 processing elements. What is the relative utilization of all the 9? If one fellow is busy for 100% of the time when the algorithm is running, and there is one fellow which is only taking 10% of the load,